I'm going to talk about the environmental challenges with the use and disposal of plastics. As an overview, I will focus on, first of all, plastic production, just some of the backgrounds about how we make plastics and what makes plastics such a useful material for us, why plastics are a valuable material, then discuss a little bit about plastic disposal, and how, if we don't dispose of it correctly, it ends up in the environment, and then the environmental consequences of plastics. So I'm going to focus on the large items of plastic today as an introduction. So plastics itself as a material, the word plastic refers to any form of material that can be molded into a shape for any real application by heat and pressure. And there's lots of different forms of plastics, and there's many different ways that plastics can be formed. So the three main ways of talking about it is through petroleum, coal, and cellulose. So petroleum and coal, they're both non-renewable sources, whereas cellulose is a renewable source. They are the building blocks of plastics. And to create a plastic material, we have to start off with the monomers. Once we take the monomers, we can, they are merged together through polymerization, which leads to a polymer and long-chain molecules like this. And depending on the different constituents that we add to the constituents monomers, we can make different polymers that have different applications and different properties. And we can make our plastics more durable or more resistant to degradation when we add plasticizers, stabilizers, and other additives. So there's a whole host of different applications that plastics can be used for. It's very flexible in that we can get, there's lots of choice, and different plastics can be used for different applications. We can split plastics into two key groups, thermoplastics and thermosets. The thermoplastics are the type of plastic that can be melted and harden and soften, and you can repeat the cycle over and over again to reuse the plastics. The most, one of the most common would be polyethylene. So it's the type of plastic that can be recycled, so we can use it for other applications and repurpose it where necessary. Thermosets are slightly different. Once plastics have been formed, and they are permanently hardened once set, so it's very difficult to recycle them and repurpose them. Plastics themselves as a material are strong, they're lightweight, and they're flexible, and they're durable. So again, lots of different applications that plastics can be used for. And they have really good optical properties. They can be glossy, they provide color, and they also provide a clarity. They can be molded into different shapes and sizes. They are heat and electrical insulators. They don't corrode or decay, and they're cheap and dispensable. And they're also resistant to chemicals, water, and greases. And they have a mechanical strength. So they're very useful. And if we look back to the 1940s, plastic was considered to be fantastic. As you can see from these adverts, wrap everything in cellophane. I thought they were quite interesting. So from around about the 1950s, plastic production started to increase, and as we developed different polymers and different forms of plastic, adding new chemicals, getting different properties from them. And as you can see through the graph, it's an exponential increase. And in 2015, it was estimated that about 322 million tons of plastics were produced worldwide, and that value is only going to increase. And it's been estimated in about 2050 that it will be 1,800 million tons of plastic produced. Different countries have different levels of plastic production, and you can see that North America and China and the EU do have quite a lot of plastic production in those areas. Now, this increased demand that we have on plastics will mean that there's going to be an increased amount of plastic waste developed once it's been used, and because of that, we need to treat that in the right ways. The plastics themselves are fantastic because without them, we wouldn't have had many developments in medical technologies, in engineering technology, and I think that the statement that plastic shouldn't be used is not necessarily correct here. We need to discuss that plastics themselves are really useful, and it's just what happens to them when they've reached their end of their usefulness and when they reach the end of their life, because they are really good for many, many different things. Unfortunately, only 50% of all plastics will be used once before they're thrown away. So these are the single-use plastics, and when they're thrown away, they can go through many different routes to be recycled or repurposed. And unfortunately, if we look at the global levels, it's only about 5% of all plastics that are produced are efficiently recovered, whether that's recovery through waste systems, recycling systems, or energy production. This is actually from Oslo. This is the Oslo waste facilities. And if we look at this study that came out recently, you can see that the primary waste generated is only going to increase based on the estimates we showed on the previous slides. The number of plastics discarded is going to be overtaken by the number of plastics that are being incinerated and recycled. And that's as we develop better and more effective technologies for repurposing plastics and closing the plastic cycle. I'll discuss the circular economy later, but we really need to work on the ways of getting plastics from production back in and keeping it within the production loop so that it doesn't escape into the environment. If we look at the global levels of primary production here, you can see that there was about 8,300 million metric tons produced, and they're used in primary and secondary different sources. But when you look at the calculations that were made, over half of that was discarded and wasn't recycled. So this is the loop that we're seeing at the moment. Is there's a start, a middle, and an end, and very little is making its way back to the start. And we want to see this as a full circle, with hopefully the discarded section made much, much smaller so that we can prevent its entry into the environment. So I've been discussing plastic in an overall view, but we need to also consider what happens when it gets to the environment. There's a number of different routes that cause plastics to enter the environment, and unfortunately, humans are normally the prime source of the introduction to the environment. We can lose plastics directly by inputting it into the ocean. We can lose plastics from our bins when we actually dispose of plastics correctly. If there's high weather or there's winds, they can escape these recycling and recovery systems. We also see plastics washed into rivers, which will eventually be transported to the ocean. And unfortunately, if plastics don't remain in the terrestrial environment, they will end up in the ocean, because that's where all rivers lead to. And it's important for us to understand all of these sources of plastics so that we can try and stop the plastics entering the environment at source, rather than trying to deal with the cleanup that happens, because that gets more problematic, and it can be extremely costly to clean up the ocean when, if we clean it up on land beforehand, it's a bit easier. This is just one image of a beach in Norway. As you can see, it's littered with plastics. So we are finding plastics in the environment from the terrestrial ecosystem, the aquatic ecosystem, and the marine. And that's floating on surface waters, washed up on beaches, even sinking to the seafloor. Plastics of all different types and quantities, from user plastics to fishing debris, and most type of plastic, you could probably find at least one item of it in the environment. So every type of plastic has the potential to reach the marine environment. So once the plastic is in the environment, we have to consider what happens to it. Now, one implication is that plastic will begin to break down. And I'm not going to go into this into details because it's going to be brought up later. But we have to consider that plastics will break down through mechanical, chemical, and biological processes, which will go from the macroplastics, so the large, visible items of plastic, down to the smaller microplastics, and finally, eventually, nanoplastics, which are even smaller to see or even harder to find. We have to understand that the implications of all of these different types of plastics, the different sizes, could have different consequences on the environment. Again, Andy's going to be discussing the implications on microplastics later, so I'm not going to discuss them. I, however, will talk about the problems with macroplastics. So when macroplastics are in the environment, we can first of all talk about habitat degradation. Plastics littering, let's say, shorelines, they can affect the habitat that animals are living in. They can prevent organisms such as plants growing if they block sunlight. They can even, as they are moved around in the environment, they can cause damage to coral reefs and mangroves because they're being moved around and they cause breakages. The habitat itself becomes unsightly. The visual quality is affected, which can have knock-on effects to tourism. If a beach is littered in plastic, it's highly likely that less people are going to want to spend time in that region, which will affect the local economy and the tourism sector within the area. We also have the effects on organisms. The main effects are ingestion and entanglement. I've chosen not to put too many pictures on because they're very easy to find on Google if you just search it. But with large items of plastics, we can discuss ingestion to, if it's small enough, the plastic can eventually leave you, or leave the animals. But the larger the plastic, the more likely it is to cause blockages and internal damages. And in some cases, it can lead to death of organisms. We've all heard the story about the Cuvier's beaked whale that stranded on the coast of Norway, and it was compact with plastic bags in its stomach. Unfortunately, it was also malnourished because it had no chance to get nutrients, so there was no space for food, which subsequently led to its stranding. Plastics also, if they're in large quantities in the environment, can lead to the entanglement of organisms, which, if they're unable to escape, will lead to their death. And this can be entanglement through lost, abandoned, or discarded items of litter, including fishing gear. And that can have substantial implications when we're considering large fish stocks. If we've got ghost fishing occurring, we could lose fish stocks and populations without our knowledge. The implications of ghost fishing are still not quantified in great numbers. And we can also consider the transport of alien species. Now, this is when plastics are floating in the environment, they can be distributed on surface currents or water currents. And if an animal has decided to hitch a ride or start laying its eggs on it, it can transport animals from one area of the ocean to another area of the ocean. And by moving species from different locations, it can cause impacts to populations in the new area the animal has moved into. And this could have effects on the native species by if there's competition introduced, and if the animals that were transported are stronger and outcompete the native populations, again, that will have subsequent effects on the population dynamics. We should also consider the effects on the food chain. If an animal ingests plastic and the population of that species are affected, it could have knock-on effects to species that are to the predator species. It could also affect prey. If a predator is removed from the environment, then there might be a growth of a prey species. So we might see some changing population dynamics and ecosystem dynamics as a result of plastic introduction to the environment. And I think we really need to stress that when we're talking about macroplastics, it's very, very clear that we can see the visible implications. But we also have to start considering the implications of the smaller items of plastic, which is why we're all here today. So we're going to discuss microplastics and maybe a little bit on nanoplastics. So if we go back to the circular economy, we can discuss plastics as a raw material. So this is the polymers and the monomers and how they're formed into making plastics. And by using appropriate design and engineering, we can produce plastics that are, have a range of different applications. And if we keep on focusing on the production and the manufacture of plastics, and we distribute it correctly and make sure that the plastic distribution line is kept together so we don't have leakages of plastic items into the environment, that it effectively reaches the consumer and it's used in the right way, and we reuse it, we repair it, and we recycle it, that plastic's life cycle and the lifespan of its durability and usefulness will continue. Once plastics can no longer be used and they can no longer be recycled and repurposed, if we can adequately collect it, so the plastics that we put into recycling or waste schemes, that they're collected appropriately and effectively, and plastics are not lost to the environment, we can continue recycling, and we recycle into new designs, productions, and the circle can go on, and hopefully it will lead to us having a small amount of residual waste. And for us to reach this circular economy, there needs to be discussions between scientists, researchers, industry, producers, and funding agencies to keep us looking at the circular design, because the less waste we have entering the environment, the easier our lives are going to be, and the less waste that enters the environment, the lower and the smaller the environmental implications.